Section 3.5 is systems with 3 variables. I can solve systems in 3 variables using elimination. Big ideas here. Systems of 3 equations in 3 variables can be solved using some of the same algebraic methods used to solve systems of 2 equations in 2 variables. We're also going to solve this using substitution. So the start of this is going to be elimination, and then we're going to switch to substitution. If the equations of 2 systems are equivalent, then a solution of the system that is easier to solve is also a solution of the more difficult system. We can represent relationships of 3 quantities with a system of equations similarly to how we represent relationships of 2 quantities. When we solve systems of equations in 3 variables using elimination and substitution, we work with the equations in pairs, using one of the equations twice. And we're going to write our answers in ordered pairs still. Here, ordered pairs, still alphabetical, are x, y, z. In example 1, we're going to find the solution of the system using elimination. So if I look here, I have 3 equations with 3 variables, and the variable that looks like it's going to be easiest to eliminate is going to be my z's. If I look, I can match these 2 together and they'll eliminate. And if I take this equation with my top equation, my z's will eliminate as well. So I'm going to have 2x minus y plus z equals 4, and I'm going to break these into pairs to eliminate one of my variables. X plus 3y minus z equals 11. Again, I'm going to do the same thing with my second set. I have to use my third equation now because I haven't used that one yet. We have to use every equation at least once. And we can choose which equation to use twice. I'm going to use the top equation twice because that gives me opposites in z's. I'm still trying to eliminate variables, and whatever I eliminate from my first set, which is going to be the z's, when I add these up, I have to also eliminate from my second set, which will be my z's when I add these up. So I get 3x plus 2y equals 15. When I add those up, add up each column. And here I get 6x. My y's cancel out as well, and I get 18. So I'm going to put these 2 together as a new system now. I'm just going to rewrite everything that I have left. I've eliminated my z's. Now I have 2 equations with 2 variables. I can go ahead and solve here for x, or here for x. Either way, I know x is 3. Once I know what x is, I can substitute it in to find y. So here I'm going to have 3 times 3 plus 2y equals 15. So we're still, just like we did with systems of 2 equations and 2 variables, finding one of our variables, substituting it back in to find another. The only difference here is that we're ultimately going to have to plug it back in to find a third variable. So right now I know y is 3, x is 3. But our original equations also had z's in them. So I need to plug it back in to find a z here as well. So 2 times 3, and we can do that into any of these equations, minus 3 plus z equals 4. Any equation that has a z in it, we can use to find z. Now I get 6 minus 3 plus z equals 4. And when we solve for z by subtracting 3, I get 1. So we write our answers as ordered pairs, 3, 3, 1. X, Y, Z, alphabetical. I'm going to do the same thing here. If I look though, I'm not going to have one variable that eliminates quite as easily as I did with my z's in the other one. I can choose to eliminate x's, y's, or z's. Here I'm going to use x's just because I have an opposite here with a 1, so it's going to be easier to eliminate because these 2 are already going to eliminate. And if I multiply it by 2, I'll have negative 2, which will cancel out with this one. So I'm going to use, we can eliminate any variable though, guys. It doesn't matter. It doesn't matter which one you pick or which 2 equations you put together, as long as we use all of them at least once. I'm going to use my top equation and my bottom equation to start with. And this gives me my first set. My second set, I have to use my middle equation because I haven't used that yet. Now, I don't have opposites here, but I can get some. I need one of my equations to be the opposite of 2x, which is -2. So I'm going to multiply the bottom by 2 all the way through because it's already a negative x. So -2x minus 4y plus 2z equals 20. Now that I have my equations, I can go ahead and add these up. My x's cancel and I get -y plus 3z equals 13. X's cancel, I get -3y plus 5z equals 27. Now I have two equations with two variables, so I'm going to go ahead and rewrite these as a system. I've successfully eliminated my x's for now, and that's what we want. Once we get to this point right here, it's the same as we've been doing since section 3.2. Okay, I don't have opposites right now, but I can get some. I'm going to multiply the top by -3 all the way through. And when I do that, I get positive 3y minus 9z equals -39. And what that allows me to do here is when I add these up, my y's will cancel. So we could have also picked to eliminate our z's here. Doesn't matter. I just picked my y's, just an easy multiplication by -3 rather than having to change both z's. We add these up, y's cancel, I get -4z equals -12. We divide, and I get z equals 3. Once I have one variable, I plug it into any equation that has that variable and just one other variable. So I'm going to plug it in over here for z. I also could have plugged it in here for z, but I just have room on my right side. So -3y plus 5 times 3 for z equals 27. Solve for y, adding and subtracting first, then divide, and I get -4. I know y, I know z, but keep in mind, originally we had an x as well, so we're going to have to plug those both in to any equation that also has an x in order to solve. So x minus 4 for y plus 2 times 3 for z equals 3, I think. Y -4 z3. Yep. And we get x equals 1. So here my ordered pair is going to be 1, -4, 3. So again, once we get rid of our first variable here, my x's, I put my two equations together and we solve it the exact same way we have been until we have to find that third variable. Feel free to pause here and give this a try if you'd like. I'm going to go ahead and eliminate my y's right away. I have opposites in this pair and in this pair. So I'm going to use my first two equations together. X minus y plus z equals -1. And x plus y plus 3z equals -3. Then I have to use my third equation because I haven't used that one yet. And when I go to pick which equation I'm going to use again, the positive y is going to cancel out my y's. Remember, we eliminate the same variable from both sets, otherwise it doesn't work. So here when I add these up, I get 2x plus 4z equals -4, and 3x plus 5z equals -3. Now I'm down to two equations that have two variables in them, x's and z's. Same two variables in my two equations, so I can put them together as a system. And once I get to this step right here, it's the same as we've been doing since section 3.2. I don't have opposites, but I can get some. 2 and 3 both go to 6. So I'm going to multiply the top by 3, the bottom by -2. Remember, we want opposites, so I need opposite signs there too. 6x plus 12z equals negative 12. We distribute it all the way through. Minus 6x minus 10z equals positive 6. Distribute it all the way through. Now that I have opposites here in my x's, I can go ahead and add these up. And I'm going to get 2z equals negative 6, so z equals negative 3. I've got one of my variables. Now we're just going to work backwards to find our other variables. Plug it into one of our equations that has a z and just one other variable. Simplify. Add or subtract. And then divide. I have two variables here. Now we can substitute those back in. X is 4, z is negative 3. So I get 4 minus y minus 3 equals negative 1. And we could have plugged them into any equation here. Subtract and divide. And I get y equals 2. So 4, 2, negative 3 is my ordered pair. X, y, z. Feel free to try this one. I'm going to eliminate y, so I'm going to use my first two equations because those already have opposites. And then I'm going to use my bottom two equations. I have to use the middle one because I haven't used it yet. And I'm going to reuse the bottom equation because my signs are different there, so it's going to be easier to get opposites. I'm just going to multiply by 2, which gives me 4x minus 2y minus 4z equals 10. Remember to multiply all the way through. Now we can add them up and get our smaller systems. I've eliminated y. And I've eliminated y. Now that I have my two variables and two equations, I can put them together into a system. And I can solve. Here, I don't have opposites, but I can get some. I'm going to multiply by negative 2. Because that's going to eliminate my x's. It's going to give me a negative 6, so 6 and negative 6 when I add up gives me 0. Divide. And I get 2 for z. Once I have one variable, I substitute it into another equation to find my next variable. Divide by 6, and I get x equals 4. X is 4, z is 2. So 4 minus 2y plus 6 equals 12. Y equals negative 1. So I'm going to get 4, negative 1, 2. So again, we pick a variable to eliminate right away. And I picked y's. So I picked these two equations so I can eliminate a y here. And I have to use my third equation. And then I pick one of my other equations to use again. Here I picked my bottom equation because I can easily get them to be opposites in my y's by multiplying by 2. And I have to do that all the way through. Once I combine those, I take my two equations, put them together into a system, and I solve it as a system of two equations in two variables. I'm going to stop this video here, and I'll continue this section with substitution in another video.